Okay, we're ready to begin, and you're ready to begin Algebra 1, and you have to do that over the summer, so you have to do it without my help initially. This video will be a little bit long, hopefully the rest will be shorter. So we're going to be starting with Chapter 1, Expressions, Equations, and Functions. And here are the 7 sections in Chapter 1, and we are going to begin with evaluating expressions. There's 2 vocabulary words right there. What does it mean to evaluate, and what is an expression? And before you do the practice, you should read the study guide. So in general, you should read the study guide, then attempt the practice, and then check your answers, and then check any assignments I've given that you might need to submit a response on Canvas as a result of your work. All right, so let's start with evaluate expressions. So here's practice 1.1, and you'll find this on Canvas. And notice I'm telling you that you should do all of them, numbers 1 through 31. I believe this should be a review for most of you. If not, then this lesson should help. So one of the first things I want you to recognize is that anytime you're doing work, you should have a name, a date. Today is the 17th of June. Some people put the day before the month, those in Europe. And what are we working on? Section 1.1. That's pretty much the minimum you should have. You don't have to write evaluate expressions, but name, date, assignment, upper right-hand corner. And anytime you are recording your work, you should write the problem down. Yes, I know it's here, but when you go back to look at it, you can see if you made a mistake. It's easier to see if you have the original problem. They're asking for the operation indicated by the expression. This is an expression. It contains a number and a variable. And the operations are multiplication, division, addition, subtraction. And so this, of course, is multiplication. And just as a reminder, let's look at each of these. You'll have to tell me what the operation is, but do you remember what the answer is to a multiplication problem? That's a product. Do you remember what the answer is to a subtraction problem? That's a difference. Do you remember what the answer is to a division problem? That's a quotient. Now, again, this is asking for the operation. In this case, it was multiplication. And finally, the sum. I'm not trying to confuse you. I'm just trying to remind you of certain other vocabulary words. Okay, now we're getting into the meat of the section. This says evaluate expressions. What does it mean to evaluate an expression? Again, here's my expression. Evaluate means to plug in. I'm just going to do a couple example problems just so you can see how you should do it. So here's my expression, y plus 7. And sometimes you'll see a semicolon. We're going to see what that expression is equal to when y is 5. So we're evaluating by plugging in 5 plus 7, and the answer is 12. Work vertically. Now, a lot of us like to put an equal sign, and then it does change an expression into an equation. They sort of go hand in hand, so I'm not going to split hairs over that. Just recognize that an expression generally does not contain an equal sign, but obviously when you evaluate, you are finding the equivalent of that expression when the value of y is 5. Pretty sure you can handle the rest of those. Just a couple notes. Number 13 involves a fraction, and I know we all love fractions. So here's a 2/3 times t, and I'll tell you what, I'll put this in quotation marks and I'll give you a different value for t. Let's make t equal to 9. And so when I'm working with fractions, I like to make everything a fraction, and then you multiply across the top, you multiply across the bottom, and this of course can be reduced to 6/1 or 6. Generally I like to work vertically, but in this case working horizontally sort of just makes some sense. Okay, another fraction is number 15. That's an addition fraction problem. So here I have w, here's my expression, w plus 1/4 when w is, and they make it nice for you, again, I'm going to put 15 in quotations because I'm going to use a different number. And 5/4 plus 1/4. And common denominator, when I'm adding fractions, they need to have this, they need to be the same size. You can't add two different sizes and get, like if I have one of these and one of these, I don't have two of anything because they're different. So if I have 5/4 plus 1/4, then I have 6/4, which again can be reduced to 3/2. So that was that with different problems, different values. Let's look what comes up next. We're talking about powers. Write the power in words and as a product. So in 17, squared, this entire thing is a power. This is the base. This is some vocab you should have read in the study guide. This is an exponent. And how would we say that in words? 7 squared. And as a product means, remember, go back to that initial couple of problems, 7 times 7, when 7 squared. So you can do 18 and 19, I'm fairly sure, on your own. Write the power by the words or the product. For example, number 20, I'll do this and say, suppose it was 6 times 6 times 6. We would say 6 cubed, or 6 to the third. 6 to the third. Write the power by the words or the product. So this is a power. Okay, and evaluate the power. Whoops. Evaluate the power just means to find the value. 3 squared is what? 2 to the 4th is what? 1 to the 5th is what? Evaluate the expression. Again, it's an expression, so it contains a variable. So if I want to find the value, I have to plug the number in. Let me just do one of those. 26 x squared when x equals 5. Well, evaluate means to plug in 5 squared, and when I evaluate that, I get 25. And then everybody's favorite are the word problems. This is a pretty good introduction to sort of expressions. Like, why do we use expressions? Math people don't like words. I shouldn't say that. I don't like words. I prefer symbols. So this is a problem about ordering custom blinds. The instructions are to measure the width in inches and add ½ an inch. So they tell you that this can be represented by the expression W plus 0.5. But here's where the expression versus equation kind of gets blurry. So I'm going to say that blind width equals W plus 0.5. So here's my expression, but I'm turning it into equation because I want to know what that expression represents. And in part A, W equals 27. So your blind width equals 27 plus 0.5. Your blind width equals 27.5, and that was in inches. And it's always nice to give at least a sentence response or word response. So you should order a blind width of 27.5 inches. So a little bit about what I'm expecting for work, and hopefully that reminded you guys how to evaluate what an expression is, what a product is, what a base, an exponent, so a lot of vocab, which is essential foundational vocabulary. And That's 1.1.